Hello everyone. As part of AWS ECS training program, today let us understand overview of ECS architecture and components. First of all, let's talk about ECS layers. We call them as components: capacity, controller, and provisioning. First, let us talk about capacity. It is all about the options what we have in order to spin up the compute plane on the ECS cluster. Either we can launch EC2 instances in AWS Cloud, or we can launch serverless architecture which is called as Fargate on AWS Cloud, or if you have on-premises environment and you want to use that as a compute to run your applications, then we can integrate on-premises compute. It could be a virtual machine or a physical server. What is meant by controller? It acts like a scheduler. It will decide on which compute node it has to launch your application. What about provisioning? It is all about the options what we have in order to manage ECS cluster. One is CLI, Copilot, Management Console, then we have Cloud Development Kit, CDK, and then we have SDK, Software Development Kit. We can use any one of these options to provision or to manage your ECS cluster. Now let us see what are the components we have in Amazon ECS. Same points I have written here. ECS provides three major layers: provisioning, controller, and capacity. And then provisioning is all about the options that are available to manage your ECS and to run your applications. The final goal of ECS cluster is I want to run my application as a container. Then what are the options we have? We can choose according to our requirement. Controller. It is just a software. That software is called as scheduler, where it will take a decision on which compute node this particular application can be launched. We don't need to take any manual decision. That will be done by your scheduler. Finally, we have ECS capacity. As I told you before as well, EC2 on AWS Cloud or serverless architecture on AWS Cloud, or we can use on-premises virtual machine or a service. Finally, what are the capacity options we have for AWS resources? We can use either AWS Regions. What does it mean? I can spin up my compute across multiple regions so that I can establish a communication between them and I can provide more high availability. Because if one region is collapsed, I can provide my access to my compute to another region as well without any downtime. No, I don't want to maintain like that. My specific clients are located in a specific location, but I want to maintain high availability. Then we have to go for availability zones. In a single region, your compute will be spread across multiple availability zones so that you will never see a downtime and it is more beneficial. Then we have local zones. For example, I want to spin up my resources with a low latency. Then you can go for local zones or wavelength zones. Finally, we have on-premises environment we can integrate to the AWS by using Outpost. After that, we can use ECS Anywhere to integrate that outpost to your ECS cluster so that we can spin up our applications on on-premises environment as well. For that, first you have to integrate it to the outpost and then we can use it to the ECS Anywhere under the capacity options. These are the theoretical points what you have to remember as part of the cluster. Now, let us understand how we can deploy our application on the ECS cluster. You can take any capacity. For example, we can see Fargate profile or on-premises or EC2. What is the basic approach in order to deploy your application? First, you have to create a task definition. Before that, you have to decide which container registry you have to use. I might be storing my images in ECR, that is Elastic Container Registry, for secured and low latency, or else I can use Docker Hub, or I can use any other third-party registry. Choice is ours according to our requirement. Most of the cases we use AWS ECR itself. After that, we have to create a task definition. In that, I have to specify what are the parameters we want to use, like CPU, memory that you want to allocate to the task what you are going to create. And then we have to tell how many containers you want to spin up. One task is equal to one or more than one container. It can have more than one. It is same like your Docker Compose or Docker Swarm service. It is similar to it. Here in the task definition, we are going to use either JSON format or a normal editor format. And we will define what are the parameters we want to use to run the application. Now, after creating a task definition on the ECS cluster to deploy the application, either we have to create a task, which is called a standalone task, or we have to create a service, which is a concept of replication. We can use either of these two approaches in order to deploy your application on the capacity options we have. Do remember that. After that, we can monitor our applications or the cluster by integrating CloudWatch. This is the basic workflow of how to deploy an application on ECS cluster. Just remember ECR, task definition. After that, we have to create a task or a service. Both will try to create a task, but if I use just a task, it is a standalone. It is an independent component. Or else we will be creating a service. If I delete a task, again the task will get recreated. So it is not an independent component. We will understand them in the next slide. But this is the application deployment approach. Next one. Once your task has been scheduled on the compute, who will receive the information? In every compute will have an ECS agent. That agent will receive the information, then it will try to spin up the task. In the task, you might have defined from where you want to pull the image to create the container. It will contact that particular registry and then it will search for that image. If it is available, it will download and then it will spin up the container. If your task is having more than one container, it will spin up all the containers and then your task will get created successfully. And then that information will be sent as an acknowledgement to your cluster. That is a control plane. This is the basic workflow of how the task will get scheduled and who will receive the information on the compute to spin up the task. Let us see the next one. If you take a Fargate profile, for example, and you take a service as an example, first we have to create a task definition, as I told. After that, we have to define a service. In the service, you will tell how many tasks you want to spin up, where you want to spin up them. That is called as placement. And then it will start creating your task. If it is a Fargate profile, it is a serverless architecture. One task is equal to one EC2. And this particular Fargate will try to spin up that particular task. And the billing will be applied only for the amount of resource this particular task has been used. And then this particular Fargate will have an ENI. That ENI will be used for communicating to the applications which are running inside. It might be having one container or more than one container. All these particular containers are grouped together, which is called as a task. Now this particular task will be scheduled by the service on this particular node. And this is the point of communication for your application running inside the task based on the port number. If you want to allow the access from outside, we have to integrate some load balancer. In AWS, it is called as ELB, Elastic Load Balancer. Either we can use ALB or NLB. Choice is ours according to the requirement. But this is the basic approach of how to create a service. For everything, if you see, whether it is a task or a service, first we have to create a task definition. Imagine it is like a launch template in AWS. In order to create an auto scaling group, we need to have a launch template. The template is a reference to spin up all the EC2 instances with the same specifications. Similar to that, task definition is a point of contact to spin up the task with the same specifications that you will define in the task definition. And this particular task will be handled by your service. If any one of the tasks got deleted, Your desired state is 3. Now the actual task is only 2. Then what it does, it will try to spin up a new task to match with the desired state. That's a benefit what we have with the service. Not only that, tomorrow, this particular task what I have the count is not sufficient due to my application load. I have to increase the number of tasks. We can do that. That is called as scaling. Either we can scale in or scale out. If you want to increase, we have to use scale out concept. If you want to reduce, we have to use scale in. We can do it at any point of time. And then we can do rolling update as well. Today I'm using this particular some version with some image. Tomorrow I want to upgrade it to the latest one. I want to apply the changes to all the tasks under this particular service. It is going to do that one by one, which is called as rolling update. There are plenty of options under this particular service. So instead of individually managing the task, it is better we create with the service, even if it is a one task. That's the best practice. Finally, this is the overall view of your ECS architecture. Either we have to create a task or we have to create a service. But for both of them, the reference is task definition. Without having it, we can't create a task. I hope this particular theoretical points will help you to understand the concept and the components what we have in ECS cluster. Thank you.